In this lesson, we're going to talk about the natural number e. And our natural number e is calculated by taking the limit of this function, 1 plus 1 over x, as x approaches infinity. And we haven't really talked about limits yet, but a limit is the number something approaches but never quite reaches. So if you plugged in numbers increasingly larger and larger and larger, this number would approach the number 2.7183. It is irrational, so this is only an approximation. If you plug e into your calculator, you would see that that decimal keeps going. It doesn't repeat, and your calculator actually doesn't have enough decimal places to represent it. So it is irrational. It's kind of like the number pi, where pi is 3.14, so on and so forth. This is 2.718, so on and so forth. So for these examples, I'm going to use this decimal approximation for our natural number e. And our natural base exponential function looks like y equals e to the x, and it follows all the rules as all of our other exponential functions did that had a rational base. Like in our other lesson where we had 2 to the x as our parent function, 2 is a rational number. So it follows all the rules. So let's take a look at what the graph of our natural base exponential function looks like. It looks just like a regular growth function because 2.7183 is bigger than the number 1, so it would be a growth function. It has an asymptote of y equals 0, horizontal one, just like in any of our other functions. And so let's take a look at some of these points. If you plug in a 0, you get a 1 out. Anything raised to the 0 power is still 1. If we plugged in a 1, we're going to get 2.7183 out, which is close to 3, so that's how I got this point here. If we squared e, we're going to get a number that's close to 7, so that's how I got this point. And then if we raised e to the negative first power, it's going to be 1 over 2.7, which is close to 1 over 3, so I approximated it at about a 1/3. And I drew my graph in, and it came out looking like this. So let's take a look at what it's going to look like if we add a 1 to it. Well, we know from experience in our last lesson, adding a 1 to our exponent is going to move our graph to the left. So if we plug in a 0, we're going to get e to the first power, which is close to 3, but not quite. And there's my point there. If we plug in a 1, we're going to get e squared, which was close to 7. And if we plug in a negative 1, we're going to get e to the 0th power, which is 1. And if we plug in a negative 2, we're going to get e to the negative first power, which is about a 1/3. So I'm going to go ahead and pencil this graph in, and you're going to see it has moved to the left by a factor of 1. Every single point on this graph did. Now what happens if we subtract a 1, just like in any of our examples in the other lesson? If we subtract a number and we move our graph up or down, and this is going to be a down case, we're going to move our horizontal asymptote with it. And since we're moving down by 1, our horizontal asymptote will also move down by 1. So it is now y equals negative 1. So let's go ahead and plug some numbers in. If we plug in a 0, we get e to the 0 is 1 minus 1 is 0. If we plug in a 1, it's e to the first power, which is 2.7 approximately, minus 1, which is 1.7, close to 2, but not quite. If we plug in a negative 1, we get e to the negative first power, which is 1 over 2.7, which is about a 1/3, minus 1, which is about minus 2/3. And you can see from these dots that it's going to get closer and closer to this line, but never touch it. And it's going to increase like this. All of our points here have moved down by 1. And that's our natural number e and our natural base exponential function.